In this video, we are continuing section 1.2 on absolute values, and we're going to think about absolute values as distances. Okay, so the key fact is when we have the absolute value of a minus b, this represents the distance between the numbers a and b. So let's look at a few examples to see if we can convince ourselves that this is the case. So if I have the absolute value of 7 minus 4, I'm going to draw a number line, and I'm going to put the numbers 4 and 7 on it. Okay, and if I think about those numbers, and I think about the distance between them, so from 4 to 7, well, those are 3 units apart. 4, and then 5, and then 6, and then 7. But if I also just do the subtraction, 7 minus 4, that's 3. Absolute value, it doesn't change what it is, so it stays 3. So this first one, I get 3. That seems to match the fact that the distance between those numbers is 3. Well, does the same thing work if I have a plus sign? So it turns out, yeah, I just have to use some algebra to manipulate it and rewrite the expression. So with a plus sign, I can rewrite that as a minus, and I need it to be a minus for this thing to be a distance. So how do I do that? I'd get 7 minus something. So what would go in the parentheses so that this whole thing matches the 7 plus 4? Well, it would have to be a negative 4, because a negative double negative, and that becomes this positive. Okay, so so what are the two things I'm subtracting? I'm subtracting 7, and I'm subtracting negative 4. So those are the two numbers I put on my number line. So this time I'm going to put negative 4, that's further to the left, and then positive 7. And then, well, what's the distance between those? Well, the distance between those, well, from negative 4 to 0 is 4, and then 0 to 7 is 7. So in total, that's 11 units apart. And that does match what we get when we do this. 7 plus 4 is 11. Absolute value, it keeps that as 11. Okay, so these pictures kind of check out with this fact that the absolute value of something minus something, well, it does actually represent a distance. Okay, so one of the things that this can help us with is solving equations or inequalities, and we'll see those in just a bit, that involve absolute values. So let's do that. I got absolute value of x minus 15 equals 3. So there's a few ways I could solve this, but I want to do this with distance because we've just been talking about distances. So the absolute value, I'm subtracting two things, which means it's a distance. It's the distance between x and 15. And that distance equals 3. Okay, so let's draw this on a number line. So I draw my number line. So it's saying the distance between 15, the number 15, and some unknown number, I don't know what x is, but the distance between 15 and this unknown number is 3. So if I go 3 units away from 15, which could be to the right, or 3 units to the left, that's where this mystery number x has got to be. So what are those spots? If I go 3 to the left, well, I'm at 12. If I go 3 to the right, I'm at 18. So I could either be at 12 or I could be at 18. So that's what x could be. 2 possible answers, 12 or 18. And I got it. There's another possible way I could have solved this equation that involves thinking about like a positive case and a negative case that you might remember from having seen absolute value equations before. We'll see that later in this chapter. But for right now, I want us to focus on solving these absolute value equations using this distance method. It's actually going to make it a lot quicker once we get practice and we get comfortable with this method. Okay. All right, let's solve an inequality this time. I got absolute value of x minus 10 is less than 2. So I also want to put an interval notation and on a number line. Okay, absolute value of something minus something means it's a distance. So subtracting x and 10, distance between those two things is less than 2. So let's put this on a number line. So I'll draw my number line. So distance between the number 10, I'll put a tick mark at 10, and some mystery number x. Well, that distance, let me go 2 in each direction. So 2 to the right, 2 to the left. Let's go 2 in each direction. If I do that, 2 to the left is 8, 2 2 to the right is 12. So where am I allowed to be? So if I was right at where 12 is, my distance away from 10, I would be 2 units away. But that's too far. My distance has to be less than 2 units away. So could I be somewhere like here, like 11? Yeah, absolutely. Then I would be 1 unit away, and 1 is less than 2. So I can be at places like this, like at 11. Could I be somewhere out here, like where 15 is? Well, my distance would be 5. That's too big. That distance is not less than 2. So that's too far out. In fact, I could be anywhere from 10. Oops, sorry, I don't want to erase. Let's draw. Okay. I could be anywhere from 10 up until 12, but I can't be right at 12 because then my distance is too big. It would be exactly 2. I need to be less than 2. Open circle at 12. And the same thing in the other direction. I could go anywhere up until 8, but if I reach 8, now my distance is 2 units. I'm 2 away from 10. That's too big, so I got to put an open circle. Okay, so I'm allowed to go up to 2 units this way to the right, up to 2 units this way to the left, but no further. Okay, so I got my answer shaded on a number line. In interval notation, this is 8 up until 12. The endpoints are both not included. They both have open circles. So parentheses at both. And that's my answer. Okay, so this might look a little slow, especially if you're used to solving these absolute value inequalities in a different way. But as we get more practice with these, it's going to be very, very quick to do it this way. So it's especially advantageous. Okay, let's do some more examples. What if I now flip the inequality and make it a greater than or equal to? Okay, well, let's think about it as a distance. So absolute value of something minus something is a distance. This is the distance between, I'm going to just abbreviate those words, x, mystery number, and 10. That distance, I'll put it in quotes, that distance is greater than or equal to 2. Okay, so let's go to my number line. Number line. Centering it at the number 10. It's the distance between 10 and something. So centering at 10. And I'm going to go 2 units each way, just like I did before. So 2 units to the right. I know that puts me at 12. 2 units to the left. I know that puts me at 8. Okay, so this time the distance can be equal to 2. So I am allowed to be at both of these endpoints because of that equal sign. That's where the distance is equal to 2 units away from 10. Could I be at somewhere like 11, where my distance is 1 unit away? That's too small. The distance has got to be greater than or equal to 2. So I cannot be just 1 unit away. I can be beyond, anywhere beyond the 12, because that would be greater than or equal to 2 units away. If I go 2 units away from the 12, I'm here. That's fine, but I can also go anywhere beyond that. That's why I'm shading in everything beyond the 12 as well. And similarly to the left, if I go 2 units to the left, I'm at 8, which is fine. But I'm also allowed to be bigger than 2 units away. So I also want to shade in this stuff, everything beyond 8 on the outsides. Okay, so this time I was shading everything on the outsides of those endpoints because my distance could be greater than or equal to 2 units away. Let's put this in interval notation. This starts negative infinity up until 8. Remember, negative infinity is always a parentheses. I can never actually reach it. 8 is included, so bracket. When I have more than one interval like this that I need to write, the next one starts at 12. It's included, so bracket. And then onwards to infinity. Infinity always has a parentheses. When there's more than one interval like this, I have to combine them with the union symbol, which kind of looks like a U like this. This is the union symbol. Okay. So that's my shaded number line, and that's the answer in interval notation. Cool. All right, let's do some more examples. Okay, so now this time, let's up the difficulty a little. Let's throw a coefficient in front of the x. Okay, so absolute value of 3x plus 12 equals 5. Okay, so what I'm going to do first is if there's a coefficient like that in front of the x, let's factor it out. So if I factor out the 3, I'll be left at x, and then 12 divided by 3, well, that becomes plus 4, and then equals 5. And now inside of my absolute value, I have something, 3, and then times something else, something times something. And there's a property of absolute values that says if I take the absolute value of something times something, well, it becomes the absolute value of the first thing times the absolute value of the second thing. In other words, I can split up the absolute value into two. So let's do that. I'll get absolute value of 3 times absolute value of the x plus 4, and then equals 5. But we know what the absolute value of 3 is. Well, it's just 3. So I get 3 times the absolute value of x plus 4, and then equals 5. Now that I have this number outside of the absolute value, now I can actually move it over to the other side. I can divide it over to the other side. I couldn't do that before. I couldn't do it when it was inside the absolute value. That's actually illegal. But once it's outside, now I can. So if I divide it over, I get absolute value of x plus 4 equals 5 over 3. And now what's annoying is if I had a minus sign in the absolute value, I can think of it as a distance. But we've learned a trick. We've learned a trick for rewriting that plus as a minus. So let's use that trick. So what was that trick? I rewrite the plus as a double negative. It's minus negative 4. So if I do that, now we're talking about the distance between x and the number negative 4. So I center my number line at negative 4. And my distance that I'm going each way is, well, it's 5 over 3. 5 over 3 to the right, 5 over 3 to the left. It's saying the distance could be equal to 5 over 3. So, well, I'm going to have to add 5 over 3 or subtract it from the negative 4. So I'll have to get a common denominator. So negative 4, so remember, negative 4 is the same thing as negative 4 over 1. And if I want to get a denominator and make it 3, I multiply this top and bottom by 3 over 3. So that gives me negative 12 on the top and 3 on the bottom. So that's what negative 4 is, making the denominator 3. So now I'm going to have to do the negative 4. Sorry, let's put it in that form, negative 12 over 3 plus 5 over 3. I'm also going to have to do negative 12 over 3 minus 5 over 3 to get these endpoints. So if I add 5 over 3 to negative 12 over 3, I get negative 7 over 3. And when I subtract, I'll get negative 17 over 3. Okay, so when I added it, I got negative 7 over 3. When I subtracted it, that's the smaller one. I got negative 17 over 3. Okay, so for this problem, my distance is equal to 5 over 3 units away, which means I want to be right at these endpoints. So the endpoints are shaded in because it's equals, but nothing else. Okay, so that's my number line. And then I write my answers. There's 2 of them. Negative 17 over 3 and negative 7 over 3. So we had fractions in this problem, which could totally happen. And that's fine. We can handle fractions. Cool. All right, so that's my answer. Let's box it. Let's do another one. Let's make this thing an inequality this time. What if it was less than 5? Well, if it was less than 5, a lot of these steps that we did up here to simplify it would stay the same. I would just have an inequality. So I'm just going to put dot, 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 because a lot of the steps are going to be the same. And when I get to the bottom, I'll still have x minus negative 4 in parentheses. But I would have my less than symbol, and then the 5 over 3. So now when I go to my number line, I'll still draw my number line, centered at negative 4. And then when I go 5 over 3 to the right, and when I add 5 over 3, I get negative 7/3. And when I go 5 over 3 to the left, when I subtract 5 over 3, that still gives me negative 17 over 3. So with the inequality, it's saying that the distance away from negative 4 has to be, well, it's got to be less than 5 over 3 away. So because there's no equals, I cannot be at these endpoints. They'll both have open circles. And my distance can be less than 5 over 3 away. So I can be anywhere within these two endpoints. Because anywhere within the endpoints, my distance is less than 5 over 3 away from that negative 4. If I go somewhere beyond, like out here, well, now my distance has gone bigger than 5 over 3. That's too far. Okay, so that's my shading. In interval notation, I'll get negative 17 over 3, comma, negative 7 over 3. Neither endpoint is included, so parentheses, parentheses. That's my answer. Okay, part C. What if I flip this and make it a greater than symbol? Well, a lot of the simplification is the same, except flip that inequality. Now I'll make it a greater than 5 over 3. The stuff on the left is still the same, x minus parentheses negative 4. So my number line stuff is still going to be the same. It's going to be similar. The shading will be different. Still centering it at negative 4. If I go 5 over 3 in each direction, I know the endpoints. Negative 17 over 3 and negative 7 over 3. But this time I want my distance to be bigger than 5 over 3 away from that negative 4. So there's no equal sign again here. So still open circles at these endpoints. But I want my distance to go beyond those endpoints because it's bigger than 5 over 3 away. So I go beyond and outside of this endpoint and similarly outside of this other endpoint. That's where my distance is more than 5 over 3 away because this is a distance of 5 over 3 to the right. Cool. So let's write this in interval notation. The first interval is negative infinity. That's always a parentheses, comma, negative 17 over 3. That's not included, parentheses. And then union, because there's another interval, negative 7 over 3, parentheses. That's not included, comma, infinity. Infinity always is a parentheses. And that's my answer. So I got my shading, got my interval notation. Nice. Okay, let's do some different flavors of examples. So what if I have like a negative number now on the other side of the equation? Well, there's a quicker way to kind of recognize what the answer is going to be here. So, the left-hand side, something minus something and an absolute value. That's some distance. I won't bother writing out the whole thing, like distance between x and 9. Because it turns out I don't need to. This is saying the distance equals negative 8. The distance between something and something is negative 8. Well, that doesn't make sense. Like a distance can't be negative. And all the problems before, above this, they were positive distances. A distance cannot be negative. So if I try to put this on a number line, it's saying shade in the stuff where the distance is negative, but that's impossible. So there's nothing to shade. It would be an empty number line. So the problem wants me to solve for x and figure out what values of x work, but nothing's going to work. So I would say no solution. So on a number line, it's empty. And as an answer, the best I can do is put no solution. The best I can do is put no solution here. Okay. All right. So for part B, I have a negative number, but this time an inequality. So this time it's saying I want my distance to be greater than negative 8. So this time it says my distance is greater than negative 8. Well, when is that going to happen? When is a distance greater than negative 8? Well, a distance is always non-negative. It's always greater than or equal to 0. So if it's always greater than or equal to 0, it's definitely bigger than negative 8. So this is always true. This is always true. No matter which two numbers I pick, if I find the distance between them, the smallest it could be is 0. Like if I pick the same number, there's no way the distance could be smaller than negative 8. It's always going to be bigger than negative 8. In fact, it's always going to be bigger than or equal to 0. So on my number line, this time, well, everything's going to work. Everything's going to work because the distance is always going to be bigger than any negative number. So everything that's shaded in. Interval notation is negative infinity, comma, positive infinity. That's my answer. It's a little weird, but that can happen. I can shade everything. What if I flip it? What if I say now it's less than negative 8? So this time I think the distance is less than negative 8. Let's think about that. Now it's saying my distance has to be less than a negative value. But a distance, if it was less than a negative number, that means it's even more negative. That doesn't make sense. A distance can't be negative. If it was less than negative, it would be even more negative. That would force it to be negative. That doesn't make sense. So that's like part A. It's saying that the distance has got to be negative here. That's impossible. So again, my number line is empty. This is never going to work. So for my answer, I would say no solution. That's kind of the best I can do for my interval notation. I can just say no solution. Alrighty. Okay, so I want to wrap up this video with a warm-up problem for you. Okay, so I want you to solve this absolute value inequality and state your answer in interval notation and represent it on a number line. So pause the video and try this for about 3 minutes. Again, like I mentioned in the videos for the last section, these times where I give you in the videos to pause and try a problem are maybe the most important times of the videos, because it's a chance for you to engage with the stuff that you've seen and really practice it on your own for the first time. You'll get more opportunities to practice it later, but really take advantage of this now. It'll set you up better for those later attempts going forward. So pause the video in 4, 3, 2, 1, pause it, and try this problem for about 3 minutes. That may not be enough time to finish the question, but that's okay. I mostly care about you getting started with the problem, thinking about what the key ideas are, and seeing if you can then make progress with it. All right, so hopefully you did that. Hopefully you paused it and tried it for about 3 minutes. Let's talk about it. Okay, all right, so I want to try to solve this inequality. Okay, so I have a coefficient in front of the x, and we saw some examples like that before. I want to begin by factoring that coefficient out, that -2, parentheses, parentheses. When I factor it out, it doesn't get to come out of the absolute value, though. It's got to stay inside. Okay, that'll leave me with x. And then if I factor in -2 out of 8, I'll be left with -4. Okay, less than or equal to 5 out here. Now I'm going to use that property of an absolute value where if I have two things multiplied like this, I get to split it up as absolute value of -2 times absolute value of x minus 4. Cool, less than or equal to 5. I know what the absolute value of -2 is. That's positive 2. Cool, so I can evaluate that. And then times absolute value of x minus 4. This whole thing is less than or equal to 5. Now that this number is outside of the absolute value, now I can divide it over to the other side. So I'll get absolute value of x minus 4 is less than or equal to 5/2. And now that I have the absolute value isolated, now I can think of this as a distance. So this is saying the distance between x and 4, that's what the left-hand side represents, distance between x and 4. And it's saying that distance happens to be less than or equal to 5/2. So let's draw this on a number line. So let me go to my number line. The center point is going to be 4, because I'm thinking about the distance between 4 and some mystery number. And the distance I want to go in each direction is 5/2. So let's go 5/2 to the right. Let's go 5/2 to the left. If I get a common denominator and I multiply 4 by 2/2, it becomes 8/2. And if I add 5/2 to it, I'll get 13/2. So that's the bigger one when I add 5/2. If I subtract 5/2, I get the smaller one. That's going to be 3/2. Okay, so let's think about which numbers we're allowed to be at. So because of the equal sign, the distance can be 5/2 away. So I am allowed to be right at these endpoints. Cool, so we can be right at those endpoints. And then it says, well, the distance can be less than or equal to 5/2. So I'm allowed to be less than 5/2 away, so I can be anywhere closer to 4 than that. And also in this direction, I could be anywhere closer than 5/2 units away from that 4. But if I was somewhere out here, somewhere outside, well, my distance has now gone way beyond the 5/2. That's too big. This problem is saying I want the distance to be less than or equal to 5/2. Okay, that's how I know it's got to be the inside of those endpoints. Cool, interval notation now. So 3/2, comma, 13/2. Both endpoints are included. So bracket, bracket. And that's my answer. Interval notation and on a number line.